talking about theorem 11.2, which is called the exterior angles theorem. So when you see the word exterior, what are we thinking about? We're talking about outside, right? Okay, so please do me a favor. Draw yourself any pentagon that you would like to using your rulers. Any pentagon you want. I'll draw one too. Okay? How many sides does a pentagon have? 5. Yes, 5 sides. Very good. Okay, next what I want you to do is I want you to pick a side, and watch what I'm going to do first, because then you do it on your paper. I want you to pick a side, and I want you to extend one of those sides out, like this. And what we're going to do is we're going to create an exterior angle. So I'm going to call that angle 1. So this information right here, this piece is called an exterior angle. The exterior angle is the angle that's made on the outside. And then I'd like you to work your way around the pentagon and draw the other exterior angle. So I'm going to go to the side up on the top here, and I'm going to draw an exterior angle all the way out. And I'm going to call that one number 2. And I'm going to work my way all the way around the pentagon. Call that angle 3. Work my way all the way around. So how many angles should I end up with? Yeah, 5 sides. I'm going to have 5 exterior angles. Alright. So now I'm keeping the regular colors. Alright, so the exterior angles theorem, it says something that's really important, really quite fantastic. It says that if you're going to add up all these, the measure of angle 1 plus 2 plus 3 plus 4 plus 5, all of the angles on the outside, it always adds up to 360 degrees. So we're talking about the sum of the measures of the exterior angles of a convex polygon will always add up to 360 degrees, no matter what the polygon is. It could be a 5-sided figure like a pentagon, or it could be a 7-sided figure. What's the name of a 7-sided figure? Heptagon. Yeah, there you go. All right, so we have an exterior angle theorem. It's pretty straightforward. But the one thing I want you to keep in mind is notice that, like for an example, like on this side, we only extended one side of our figure. We don't extend both. We have to just extend one side of each side. We have to extend it, but only in one direction. So we don't go in 2 directions, because that would give me another angle here, and then get cut off down below. So we only go in one direction the whole way around. So one direction there, one direction there, one direction, and that all the way around. Does that make sense? Those are all the exterior angles. Okay, let's do an example together here. So I got example. Example number 2. Please draw this figure. We're going to draw a quadrilateral. Something like this. Yikes. Messed that up. So we're going to draw a parallelogram. So do your best you can to make those look all the same. And then we're going to know some information about our parallelogram. We're going to take our figure, we're going to extend our sides here. We're going to start on the left-hand side, we're going to extend that one up. Working all the way around, we're going to extend that one down, extend that one, and extend that one. So we have this exterior angle up at the top, which we're going to call 2y. We have this exterior angle on the right hand side, which we're going to call y. We're going to go all the way around. This is going to be also 2y. And this is also going to be y. So I have 4 exterior angles here. And our goal is to figure out what y has to be in order to make this work. Alright, so what do we know about all the angles of an exterior polygon that is convex? Yes, Jared, what do we got, man? They add up to 360. They always, that's what theorem 11.2 is telling us, right? So then it must be the case that 2y plus y plus 2y plus y again has to be a grand total of how much? Has to be a grand total of 360 degrees. Well, these are all like terms. So 2y plus 1y plus 2y plus y. How many y's is that? That is 6 y's, yeah. So 6 y's has to be 360 degrees. So we can use some algebra, inverse operations, and solve for y. So y has to be a 60-degree angle. So if I go back up to here, this makes total sense. This must be 120 degrees. That looks like it. This must be 60 degrees. That must be 120 degrees. And that must be 60 degrees. If we add them all up, so it's a corollary to theorem 11.2. Remember, a corollary is a little theorem that goes with or about or pertaining to the other theorem that we had. So, I need you to draw a regular pentagon. So what's a regular pentagon going to look like? No, not a house. What's regular mean again? Equal sides, equal angles. Well, I'm doing the best to draw a regular pentagon here. Maybe you guys will do a much better job than me. So here we go. This will make it all better. So this is a regular pentagon. Regular means equal sides, equal angles. Remember that. So regular, equal sides, equal angles. So the corollary to theorem 11.2 says if you've got a regular pentagon or a regular polygon, it doesn't have to necessarily be a pentagon. If you have a regular polygon and you extend one of the sides to create an exterior angle, and we'll call this angle 1 right here, then the measure of that exterior angle, the measure of angle 1, is just 360 degrees divided by the total number of sides that you have. So in this case, I had 5, right? So in this case, I would take 360 degrees and divide it by 5, which would give me how much? How much would that be? Yeah, there you go, 72. So that would give us 72 degrees. So each one of these angles would be 72 degrees. So if I went all the way around, that would be 72, all the way around, 72, and so on and so forth, all the way around. And the reason that works, you guys, is because your figure is regular. All angles on the inside are the same, and all side lengths are the same. Therefore, every exterior angle has to be the same. Do you have a question?
So n in the formula would represent number of sides?
Correct. He said n in the formula represents the number of sides of the figure. That is absolutely right. So remember, this only works if your figure is what type of figure, everybody? Regular, which means what again? Same sides and same angles. Good. Nice.